Welcome to part 2 of linear algebra basics. Last time we learned that vectors are arrows with magnitude and direction. Now we will see how vectors interact with each other and with numbers. Let's look at vector addition and subtraction. Adding vectors means combining movements. For example, if vector u is equal to 2 and 1 and vector v is equal to 3 and 4, then u plus v is equal to 2, 1 plus 3, 4. In adding vectors, we add them correspondingly. For example, we add the first vector in u to the first vector in v. We add the second vector in u to the second vector in v. So for example, becomes what? 2 plus 3. So we have 2 plus 3. And we have 1 plus 4. 1 plus 4. And that gives us 5 and 5. So vector u plus v gives us 5 and 5. Geometrically, this is the parallelogram rule. Place the arrows tip to tail and the result is the diagonal. Subtraction works the same way, but instead of combining, you are finding the difference in movement. Now, scalar multiplication. Multiplying a vector by a number is called a scalar. Scalar multiplication is used to stretch or to shrink a vector. So, for example, if we have 2 times vectors 3 and 4, what we do here is to expand or stretch the vector. To do this, the number we multiply every element in the vector. So what we have is 2 times 3 is 6 and 2 times 4 is 8. So this is how we stretches a vector. So positive scalars keep the direction while negative scalars flip it. I repeat that. Positive scalars keep the direction while negative scalars flips the vector. Dot product. The dot product is a way to measure how aligned two vectors are. For example, vector u dot vector v. So this symbol right here is the symbol that represents a dot product. If, for example, vector u is equal to u1, u2, for example, and vector v is equal to v1, v1, v2. To find the dot product, we multiply the corresponding elements and we add the results. So it means that u dot v is equal to, open bracket, I will multiply the corresponding element. So u1 times v1. So we have u1 times v1. Then we add plus u2 times v2. That is how we solve dot product. It is the sum of the product of corresponding elements. If the result is large and positive, the vectors point in similar direction. If it is 0, it means that the vectors are perpendicular. We will dive deeper into this in a future lesson, but keep this in mind that it is a bridge between algebra and geometry. Let's look at an example as regards to dot product. By given a question, U is giving us 1 and 2, and V is giving us 3 and 4. What is the dot product of U and V? So therefore, U dot V is equal to U is 1 and 2 dot V is 3 and 4. So what we do is to multiply corresponding elements, then add. So open my brackets. So it's 1 times 3. So it's 1 times 3 plus 2 times 4 plus 2 times 4. So that gives us 1 times 3 is 3 plus 2 times 4 is 8. So therefore, our answer is 11. So the dot product of U and V is 11. Real-life applications. Vector addition models forces acting on an object. Scalar multiplication shows scaling in computer graphics. Dot product helps in physics, machine learning, and even measuring similarities in search engines. Thanks for watching. See you in our next video.